We are evaluating the integral of square root of x squared minus 4 divided by x dx. So let's see, we have the choice of using sign, but for trigonometric substitution, as long as you have square root of a squared minus x squared, use x to be a sine theta. And when you see square root of x squared minus a squared, use x to be a secant theta. So why we are using x equals to 2 secant theta? Why is that? Because it helps us to simplify a radical. You get the square root of x squared, which is 4 secant squared of theta minus 4. Here you can factor out 4. You end up with secant squared of theta minus 1 that you already know how to deal. This is basically tangent squared. So you have 2 times square root of tangent squared of theta, or you have 2 tangent of theta. So let us go back to our integral. This becomes the integral of, on the numerator, you have 2 tangent theta. On the denominator, you have x, which is 2 secant theta. What about dx, right? When you're calculating the derivative of secant, the derivative of secant is 1 over cosine. You can basically apply quotient rule, and you're going to see that this is equal to 2 secant theta tangent theta d theta. So let's take this guy and move it up here. Let me rewrite this. And d theta or dx is 2 secant theta tangent theta d theta. So your dx is just 2 secant theta tangent theta and d theta. So as you can see, you can easily get rid of 2 secant and 2 secant. What's left? You're left with 2 times the integral of tangent squared of theta d theta. But how do we calculate this integral? This integral can be written as secant squared minus 1. This is 2 integral of secant squared of theta minus 1 d theta. So you have 2 integral of secant squared of theta d theta minus 2 integral of d theta. The integral of secant squared is tangent. So you end up with 2 tangent theta minus 2 theta plus constant of integration. Are we done yet? Not yet, because our integral, original integral, is written in x, but the final answer that we got is in theta. But remember that you have the substitution of x equals to 2 secant theta. Let us use that. So since x is equal to 2 secant theta is equal to x divided by 2. But what was the definition of secant? Secant is 1 over cosine theta, which is x over 2. So cosine theta is 2 over x. Well, okay. From this part, we can say that, hey, my theta is equal to arc cosine of 2 over x or cosine inverse of 2 over x. Or you could use this part as well. Write down theta as inverse secant of x divided by x. They are the same thing. They have the exact same meaning. So either this or write it this way. So this guy can be written as theta is inverse secant of x over 2. So let us go back to our right triangle. In the right triangle, if you have your theta, remember that your cosine theta is 2 over x. It means that you have 2 and x. This length here is equal to x squared minus 4. So tangent theta is square root of x squared minus 4 divided by 2. So wherever you see tangent, you're going to use this quantity. Wherever you see theta, you're going to use this quantity. So your integral is written as 2 times square root of x squared minus 4 divided by 2 minus 2 times inverse secant of x over 2 plus c. So your integral in simplified form is equal to square root of x squared minus 4 minus 2 times inverse secant of x over 2 plus constant of integration.